Our next speaker in the program, Mr. Randy Scott, who is currently serving as President, Chief Executive Officer, and Director of Rare Earth Element Resources Limited, a company that's developing a rare earth element project in Wyoming. Randy was appointed President and CEO in December of 2011 and as Director of the company in February 2012. Mr. Scott has over 40 years of experience in the mining and processing industries. His experience includes leading performance teams in operations, administration, project development, management, business development, and major improvement initiatives. Randy received his Bachelor of Science degree in Metallurgical Engineering from the Colorado School of Mines and his Master's of Business Administration from the University of Arizona. Randy, we're just so grateful and happy to have you as part of this program, representing a member of the industry looking at critical metals, and we're really excited to hear what you have to say about rare earth element resources. So welcome to the symposium, and I'll pass the floor over to you.
Great, thanks, Eric. I really appreciate it, and thank you and Marta for the invitation. It's always a pleasure to be able to share some of our thoughts and ideas with folks, and look forward to this opportunity for some time now. So I think what strikes me is that about this is that based on what I saw from your flyer on the symposium here, that you're going to get a view from somebody who's actually been in the industry now, and a company that's been slogging away for a decade or more to get to the point where we are today. A lot of lessons learned during that period of time, and I'm going to be sharing some of those with you as we go through the slide presentation here. You'll note that my cover slide talks about technology versus supply chain. I'm going to make a case, I think, or I hope to make a case that while the development of technology and the application of technology to the development and processing of critical materials is not the only thing that folks should be considering as they look to the application of new technology for the ultimate success of a project. So I sketched out my conclusion earlier, so I'm going to go ahead and give you my conclusion now, and then we'll revisit. I'm going to suggest that not only do you have to master your own technical field, but you should know as much as possible how your technology advancements fit in the competitive landscape of a global, fast-growing and critical industry like the rare earth industry. Rare Element Resources is a company, and our only project, our only physical asset, is the Bear Lodge Rare Earth Project located up in northeastern Wyoming. So I'm going to go ahead and use Bear Lodge as the poster boy, I guess, for some of the technology advancements that we've made, as well as some of the fits and starts that we've gone through. So let me go ahead and get started on that. One of the things I'm required to do, isn't this a great slide? This is what folks call a disclaimer slide. Rare Element Resources is a public company. We're traded on a stock exchange. We're regulated by the Securities and Exchange Commission. So we have certain rules and regulations that we have to adhere to. In this particular case, what I'm supposed to do is ask you to read this. However, in the interest of saving a little time, I'll try to summarize what it says. It says that I am going to be making what we call forward-looking statements. And forward-looking statements are exactly that. And you are cautioned here that the way things actually turn out may not be exactly as our forward-looking statements purported in this particular on this particular presentation. So you are cautioned to take that disclaimer to heart as we move through the rest of the presentation. Okay, as I mentioned, Rare Element Resources has one asset, and that is our Bear Lodge Rare Earth Project. I'm going to give you a little bit of background on that context, and then we'll have some discussion about technology development as well. The vision has always been, for at least a decade now, to be a long-term, secure, reliable, and sustainable U.S. source of separated critical rare earths for all of the key industries that would serve. A couple of key terms there for you: secure, sustainable, and separated critical rare earths. Those are issues that have always sort of guided the direction of the company and continue to guide it today. As a result of that, we have developed proprietary technology. We have identified what we believe is a very significant domestic resource located up in northeastern Wyoming. And we have been moving forward with exploration, identification of the resource. We've been moving forward with creation of technology, particularly process technology. And when I talk about technology as it applies to Bear Lodge, I'm talking specifically about technology associated with the process from in the ground all the way through to the production of separated rare earth elements as oxides. The supply chain and the value chain, which we'll talk about a little bit more later, obviously goes well beyond the production of separated oxides. But that is our experience and where I'm drawing some of the insights from as we move forward. So Bear Lodge, I mentioned, is located in northeastern Wyoming near a little town called Sundance. It is surrounded by excellent infrastructure, including roads, power, and water. One of the major competitive advantages of our particular Bear Lodge project is that we don't have to build the doggone biggest thing in the world in order to overcome the capital costs associated with infrastructure. We have ready access to supplies, materials, rail, roads, as I said, as well as a highly skilled labor force up in that part of Wyoming, in particular since we've seen a decline in coal production coming out of the Powder River Basin. There are an awful lot of people who have been working in those particular mines that have gained a lot of experience and skills and are readily available when we move forward with the project. I would draw your attention to the map a little bit because there's really two markers on that map. The first one is the Bear Lodge resource itself up by Sundance on the north side. And down below you see another marker for the Upton Hydrometallurgical Processing Plant. In the scheme of things, we transport ore down to Sundance, about 40 miles, down to Upton, about 40 miles away. And that's where we will build the hydrometallurgical plant and the demonstration plant, which I'll get to here in a bit. The reason for that is that particular plant would then be located on private property in an industrial park adjacent to a railroad. This is a schematic of the last 10 years or so of the project. Just quickly, you can see really the progress ramped up starting in about 2012 after we had identified a reasonable mineral resource. We continued to explore. The resource kept getting bigger and bigger and bigger. We did a preliminary feasibility study and then updated that preliminary feasibility study once back in 2014. And then in 2015, We looked to do some initial pilot plant testing of separation, and I'll tell you a bit more about that here and why we did that. We were awarded a draft environmental impact statement from the Forest Service back in 2015, 2016. But the market for rare earth elements cratered. And being a small company, which consists of, or persists on the basis of being able to raise additional capital funds to advance the project, we were unable to do that. So we put the project and the company on care and maintenance for a while, and went out to look diligently for a significant investor. And we were fortunate that we were able to find one. The company that we eventually did an equity deal with is a company called Synchron. Synchron invested $5 million approximately for a 34% stake in the company. Synchron is an affiliate company of General Atomics. General Atomics is one of the largest privately owned defense contractors in the United States. They build the Predator drone, and they are into all kinds of technology development projects all over the world as well. As part of the initial investment in 2017, Synchron had an option, a 4-year option, to acquire another up to 49% of the company for another $5 million. They exercised that option 2 years earlier, and now Synchron is a major investor in Rare Element Resources and owns approximately 48.5% of the company. As a result of the relationship with General Atomics, we were also introduced to another firm, another affiliate company over in Germany, which we call UIT. And UIT is a company that has an extensive capability for process development and engineering, with, as you would expect, many German PhDs working in that group. And we have been fortunate to be able to share some of our early proprietary work with them, and they have advanced that technology and moved it now through 2 successive pilot plant tests. And then the most recent news is that Rare Element Resources and General Atomics and its affiliates and another company called LMV, which is a design, engineer, construct company, were recently named a potential recipient of a DOE grant for $22 million towards the design, build, and operate a demonstration scale plant in Upton, Wyoming. And I'll have more to say about that in a minute. Shifting gears here for a second. I suspect that what I'm going to cover in the next 3 slides, probably most everybody knows. But what's interesting is that over the last 10 years or so, we've seen the emphasis of the market change over time as the global demand shifted towards carbon minimization and towards electrification of the world. The requirement for permanent magnets to participate in that effort is now the driving force for almost all of the development of and processing for rare earth elements going forward. So the market essentially is, although when you mine, as everybody knows, when you mine a rare earth project, you typically get maybe not quite all 17, but you may get all 17 elements. The most important ones are the ones now that are participating in the manufacturing of high strength permanent magnets. one interesting point, as I mentioned, how things change. The Bear Lodge deposit, to the best of our knowledge, has the highest concentration of europium of any rare earth project that we've seen on a global basis. And back in 2012, 2013, that was fantastic because of compact fluorescent bulbs. But when the market left that for LEDs, that market practically disappeared. And europium prices went from $300 or $400 or $500 a kilo down to $15 or $20 a kilo. So what that meant for us was, we had to shift gears. Good news was that the permanent magnet market began to pick up, and Bear Lodge has a very good concentration of those rare earth elements as well. Again, I think we all realize what the applications are for these critical elements. I just point out that the rare earths that were used in the U.S. between 2016 and 2019, 80% of them were imported from China, and we'll talk about that issue of the supply chain shortly. This is a graph from Roskill showing their projections, historical and historical actual and moving forward for the growth in magnet demand, and they're projecting for 2020 and through 2024 an increase of 6% on a compound annual growth rate, and then 5% for 2025 and 2030. I frankly find these numbers to be way low, but that's a personal opinion. But I can't help but think that the growth in demand is going to exceed these numbers simply on the basis of the almost every week, one of the large automobile manufacturers puts out an announcement that says they're going to invest $35 billion over the next 4 or 5 years to produce 30 new models of electric vehicles going forward. And I just think that this 5% growth rate is way understated from my perspective. We're in a period of time when demand is going to eventually outstrip supply fairly shortly, I think. Talk about prices a little bit. Interesting. As you all, again, probably already know, over the last decade or so, from about 2012 on, China has continued to put their authority on prices and have maintained prices fairly low over the last 5 to 10 years, and sometimes actually forcing prices even lower than average. But something interesting happened at the end of 2020, and this is a trend that is quite remarkable, really. But at the end of 2020, and for the first 4 or 5 months of 2021, we've seen a almost doubling, and in some cases more than that, increase in the price of rare earths, particularly the neodymium, praseodymium, dysprosium, terbium prices. Again, I think this is starting to reflect supply-demand issues. I think it also reflects China perhaps not having as staunch control of the market as they have had in the past. One of the things I would just note here is that in this particular slide, you see a decline at the end there in these prices. And if you've been in this business long enough, you know that what goes up quickly like that usually comes back down quickly. But interestingly enough, over the last week or two, that trend has started to stabilize. And in fact, we've seen a return to an increase in prices going forward. Not to those peaks quite yet, but it's holding pretty steady at those higher prices going forward. Okay, let's talk about technology for a minute here. My definition of these technology advancements is we're in search of innovation, we're in search of competitive costs, and we're in search of a market. The technological advancements are going to be dictated in some fashion by the market. So we've had our ups and downs, and I'm guessing that all scientists have probably seen this headline from CNN, where the really smart astrophysicist gets magnets stuck in his nose as he's trying to develop a new product for monitoring coronavirus. And it seemed like, I guess it seemed to him that was okay when he put the first magnet in his nose, but it was when he put the second one in his nose that things really got ugly for him. So, but the point here is that there will be times over in this industry and over a period of a decade where sometimes you just got to start over. And that's what we've had to do early on in the process, early on in the project itself. At this particular point in time, RER has patented and patent pending RE recovery and processing technology. And I had the opportunity yesterday to sit in on a bit of Bruce's presentation as well on flotation, and that was an issue that we had to deal with very early on in the development of the process. If you will recall from Bruce's comments, very fine-grained gangue materials and valuable mineralogy does not necessarily make for an ideal situation for flotation. So we decided early on, for permitting purposes as well, but for the fact that when we tested flotation, we were not getting very good recovery, and we were not getting very good concentrates grades out of it. So we had to come up with a different approach, and that approach is part of the proprietary technology, and we deemed it whole ore acid leaching, and nobody was really doing that back in 2012, 2013. But since then, we've seen other folks contemplating the process as well. So what we've done here is we remove clearly the material that is not rare earth bearing ore or mineral early on at the mine site at Bear Lodge, and then we transport the material which we know contains high grade mineralization down to Upton, where we go through the process of grinding it up fairly fine, and then leaching it with hydrochloric acid, and then selectively precipitating that out with oxalic acid. Now, a couple of comments on this. First of all, this approach has been used before on the basis of very high temperature acid leaching. 90 degrees Celsius or more. And part of our proprietary technology and the work that we were doing and the work that UIT has done is to drive that temperature down significantly, almost to whatever the temperature happens to be in the plant. So in addition to that, we continue to try to reduce that acid consumption going forward through application of additional technology. the probably, not probably, it is true that this is an expensive approach, and could have been uneconomic, except for one thing. Both the acid leaching as well as the oxalic acid precipitation, we recycle and recover a significant quantity of those reagents going forward and reuse them. So that's again part of the test work that's been going on and has been confirmed recently that we can in fact recycle those acids back into the process. One of the big advantages of this process is the selectivity that the oxalic acid uses when it precipitates the concentrate. Again, going back to Bruce's presentation yesterday, the flotation produces a concentrate. I think he also mentioned that Mountain Pass at this particular point in time produces a concentrate. And there are other rare earth companies or projects around the world that all produce a concentrate. And to the best of my knowledge, that concentrate is typically 50, 60% or less or more total rare earths in a mixed concentrate. Going forward, there isn't anybody in the United States that can separate that into the individual rare earth elements. So where's it go? Well, guess where it goes? It goes to China. And one of the big advantages of our oxalic acid precipitation is that it produces a mixed rare earth product, okay, that's 90 to 95% pure rare earths. And that frankly, to me, 6 or 7 years ago was an amazing surprise. But it begged the question, if you can produce that exceptional purity of concentrate, really you should be looking at moving downstream and doing the full separation rather than trying to market the concentrate itself. So that's where the focus has been over the last several years. It has been to primarily to optimize the leaching part of the flow sheet, and then to develop proprietary technology, optimize proprietary technology for solvent extraction going downstream. I just want to touch base on a couple of things here with regards to the results of the proprietary technology. The third item down on the list, significantly fewer mixer settlers. Again, listening to Bruce's presentation, he talked about 50 or 100 or 150 mixer settlers in line in a process, a solvent extraction process. And by the way, our process is essentially traditional solvent extraction with some interesting twists about it. And one of those is that we've been able to significantly reduce the number of mixer settlers, which we are optimistic will reduce operating costs, but certainly will help us on the capital cost side of things. The other item I draw your attention to is that as a result of recycling the acids, we're confident that we're minimizing waste discharge, and that the process going forward should be environmentally attractive compared with others, in particular, maybe the Chinese side of things. Okay, so we've done all this work on the technology. We've run multiple pilot plant tests, and we're doing additional work now to confirm the optimization characteristics of the process. Back in middle of last year, UIT recommended and we proposed that we take a next step beyond the pilot plant testing that it was being done at UIT. And that next step was to build a demonstration scale plant, again, somewhere in Wyoming, and we've settled on Upton, very near where the commercial plant would be built at some point. So in mid 2020, Rare Element Resources, along with General Atomics, the Electromagnetic Systems Group from General Atomics, and the UIT and LNV got together and decided that we were going to collaborate and make a proposal to DOE in response to an FOA from DOE to go ahead and build this demonstration plant to see if we could get some help financially. And we were fortunate, very fortunate, in that at the end of January we were notified that we had been selected to negotiate a final agreement with DOE to engineer, build, and operate this demonstration scale plant. The demonstration scale plant project is 36 to 40 months long. It costs $44 million. And the grant from DOE is for about half of that. We're in for a 50-50 cost share. So DOE will provide half of that, and the industrial partners will provide the other $22 million of funding for the project. The final negotiations with DOE are underway, and we remain optimistic that we're going to be able to conclude those sometime soon. I don't think I need to do anything more on this, except to say that essentially the three-year project is divided into 3 phases. The first phase is to do the basic and detailed engineering on the project, as well as to arrange for permits and licenses for the demonstration plant. Demonstration plant will we'll then construct the demonstration plant in the second year and operate for 1 year after that. The operation scale of the plant will be approximately 3 tons per day. Just a quote from the president of General Atomics supporting the project. All right. So that kind of summarizes where we are with regards to technology advancements. You'll remember that I mentioned that it's important to understand how those technology advances that scientists work on fit into the overall supply chain issues, which are enormous in the rare earth space, and you will also note quite familiar with regards to other critical materials and minerals on a global basis. And of course, that's the elephant in the room, and that's China. So this is a quick presentation of the value chain, supply chain for magnets, from production of separated rare earth oxides, that's us on the far left, all the way to the end user application, going through metal and alloy maker, magnet maker, and component manufacturer. The list of companies there are mostly, not mostly, they are non-Chinese companies. But the key here is that as many as you think there are many, many more in China doing essentially the same activities as you see from the non-Chinese side here. So we understand that and have come to learn over the last several years, and I say finally, how China has dominated these critical materials supply chains for a period of time, and there's just no question, and they're not shy about admitting it, that they have moved forward to dominate the rare earth supply chain. But it's not just the rare earth supply chain anymore. It's all the critical materials, and the critical materials that are essentially necessary to move the world off of carbon and into an electric world moving forward. This is just a quote from the Foreign Policy Group back in 2019. Yeah, and here we see some of the big differences between the Chinese economy and government versus U.S. capitalism, and the planning and effort that goes into a longer term view being presented by the Chinese. And the Chinese have taken the step of deploying state-owned enterprises and private firms to hot spots around the globe to acquire these critical mineral reserves. And it's not just that the Chinese are short these. Chinese probably already hold a dominant position in some of these critical production of some of these critical metals, and yet they still are out trying to tie up as much as they possibly can. We talked about this a little bit just a second ago, but as I say, it's not just the rare earths. The poster child for this strategy is China's dominance of the Democratic Republic of Congo's cobalt industry. As a result of investments that Chinese have made in the DRC with regards to copper and copper cobalt resources and production capabilities, China's investment in these now accounts for 80% of the export revenue and thousands of jobs from DRC. And China is aggressively, and you can't help but see something almost every week these days, China is aggressively pursuing a similar strategy of going out and acquiring positions in the lithium industry as well now, not just the battery side for cobalt, but now the battery side for lithium going forward. And that's taking place all over the world, but particularly in South America these days. And lastly, China has, over the last 5, 6, 7, 8 years now, continued to steadily acquire positions in global rare earth projects for the benefit of ownership or offtake agreements or whatever the case may be. It always surprised me how long it took for everybody to get a perspective on this strategy. The Chinese are absolutely brilliant at the execution of this strategy, and more kudos to them for it. But it puts the rest of the world in a very tough spot right now, I think. They have a strategy that consists of the following steps. The first thing they do is subsidize the domestic industry, and then as they do that, they as a result of subsidizing, they can drive commodity prices low, and that discourages anybody else in the world from making investments in global projects in that particular industry. But occasionally there are a few who are brave enough to try to fund a project and move forward. And the best example of this was the original investments that were made to bring Molycorp's Mountain Pass property on stream at the time. The Chinese, in order to control, I think, decided that they were going to drive down prices even lower, such that the new investors and their new projects would not be able to be financially successful. And as a result of that, the investors were in dire straits, had to write off their investment, and try to find some way to make themselves whole. And lo and behold, China shows up and says, "We'll take this property off your hands. We'll want to acquire it on the ownership on the basis of 5 cents for every dollar that you invested in it earlier. And we want a control of any offtake agreements going forward." Once they've done that, they continue to leverage their interest and then repeat the process over and over again. That is, in my view, the perspective on how the Chinese are moving forward steadily to control the supply of critical materials. And the foreign policy noted one particular issue. Clearly, China has moved aggressively to dominate all of these other critical industries, but one industry that they've not been able to do to dominate has been the semiconductor industry. We see that playing out every day now, or at least over the last 6 to 12 months, with the comments that are being made by U.S. world semiconductor manufacturers, and the ability to curtail Chinese participation in some of these projects going forward. But finally, there's some good news. All that sounded pretty dire, but I do think that we're on the cusp of some significant improvements in the situation. As you all know, during the previous administration, attention was focused and attention was brought to the role of China and the critical supply chain issues. And then it really played out, not just in commodity, not just in critical minerals, but we all saw it play out in COVID. So the attention really started to focus then on what was and what had been going on with regards to China and these critical supply chains. So over a period of not too long, there were 7 U.S. presidential determinations regarding U.S. supply of critical materials. And having been in the industry for about 10 years now, we've seen reports being written left and right about how some of this is very important, but then nothing ever happens. There's no commitment to investment or to assist in the development of these critical projects going forward. But following Biden's ascension to the current administration, we actually have seen some action. And we started to see some action earlier on with the Rare Element Resources Award for the DOE agreement. With that particular FOA, I don't remember, but I believe there must have been at least 20 awards focusing on critical mineral technology and development, of which Rare Element Resources was the largest, but there was a significant investment towards battery technology and development as well. So we're seeing real commitments coming from the government now, recognizing that we have to do something about this and not just continue to issue reports about how important it is. So that concludes, and I'm going to go back and say what I said at the beginning, I guess, and that's that not only do you have to be a master of your technology, but you really have to take a look at how that technology fits in the overall global supply chain, and how you can have a major impact on touch points within that global supply chain to really capture value for everybody working on it. And I guess I would just end with one other quick comment. It seems to me we've been very fortunate at Rare Element Resources because we've had access to a cadre of very, very smart technology scientists working on the project. Half a dozen or more PhD, postdoc kinds of people with years of experience, we've been able to capture the value that they brought to the company with the advancement of some of our technology. But there's a tremendous amount of opportunity out there now. And I think that because of the rapid changes that we see occurring in the world, we really need to take advantage of it. And you guys as scientists are on the cutting edge of this. And there's just, to me, the world is wide open to any suggestions or work or proposals with regards to how we can solve this problem. And again, it's not just rare earths. There's critical material questions surrounding so much more of what we need to do to be able to move off of carbon and to move towards electrification. So that is my presentation, and I'd be happy to take a few questions if we have time.
Let's give Randy a round of applause for the
Thanks.
critical talk. Randy, thanks so much. We do have some time for questions. I suspect there will be some considering your position in this industry and the excitement around this project. So we'll open it up now, the floor for questions. I'm happy to kick things off too if others require a little stimulation. Mark, you look like you have a question.
Yeah, I do. Randy, so it seems like there are lots of different dials or let's say variables in the supply chain that can affect whether something is going to be competitive or not, and if it can go forward. And so, you know, when you consider the sort of broader Chinese strategy in trying to control rare earths, are there certain points in the supply chain where you can easily flip the script on this sort of approach? I mean, obviously having a wonderful resource that's really high and in, you know, a really great grade and easy to get at, right? I mean, it, you know, but you know, are there other parts of this that can consistently, let's say, improve the competitiveness?
Yeah, I think that's a great question. And we're all sort of in search of that, Mark, as you might expect. It has come to be recognized by a few people anyway, that the competitive advantage that China has is not necessarily in any one of the touch points on the supply chain. The competitive advantage they have is that they have the complete supply chain. And they diligently work to coordinate that and the development of all aspects of that. You know, there are very few places in the world where you can reduce the oxides to metal, but you sure can in China or affiliated Chinese countries. And magnet manufacturing, you know, the Japanese know how to make magnets as well as some others, but the Chinese the Chinese literally have industrial centers now identified, and enormous buildings and companies moving in, and thousands of people being employed now to advance magnet technology and manufacturers, and to move it into the application side of things. The industrial policy of China now, I think, has shifted because they essentially control these commodities at the base now, but they're trying to shift the economy now to the higher end of the value chain, where they're manufacturing components. Clearly they already dominate the wind turbine industry, and they're very successful on photovoltaics, and so and I think what they want to do is they want to build and sell cars to the entire world. The strength that I see is the fact that they have the entire supply chain under the control of the Chinese and Chinese government. Now, are there any specific technological touch points? I would think that it seems to me that some really smart people ought to be able to figure out whether there isn't technology that substantially reduces the number of steps in the supply chain. Let's say you go from a product of a mine directly into metal to make a magnet, and skip the intermediate step of reducing the metal. And maybe there are other areas like that where it's possible to do that. I'm not sure that I've answered your question, Mark, but just some thoughts.
Randy, I have a question for you.
Sure.
Go ahead, Shubha.
Yeah, so I'm sure you're also familiar with China's like Belts and Roads initiative and stuff like that.
You bet.
So this appears to be not something just restricted to the critical metal side of things, but in general, the expansionist policies that China has, and US being the biggest creator of consumers and also being a fairly capitalist country trying to maximize its profits, let's say. Everything still gets manufactured in China. How do you bring back things to the US, or like move things anywhere at the expense of profit, while not being sort of branded as maybe a right-wing person who's like USA?
Yeah. I think that this has been the conundrum, I think, for developing supply chains and developing critical rare earths for some time, and that's that we don't have the supply chain, and we gave the supply, not gave, but China acquired the supply chain from us, so it's it's kind of like we need to get started somewhere, okay, and hopefully the rest of the supply chain will follow suit. One of the things that we always try to keep in mind is that you do need to be driven by the applications that the technology and the product can be used in. I think what's been interesting has been the original alarm was set off with regards to critical materials, particularly rare earths, by the Defense Department. When they figured out that no matter what the price, they just might not be able to acquire rare earths and for building of their applications and their components. And essentially, you know, that in some ways that hasn't changed very much. But I do see an opening here as a result of climate change activities, particularly with the potential large-scale development of demand coming not from the Defense Department, but coming from consumer-related goods, such as automobiles. Or other uses that are yet to be discovered with regards to that. So I do think that there's coming a day when demand for non-defense products is shifting more and more to the consumer, and gives an opportunity, I think, for some company or companies to come together to reestablish the entire supply chain in the U.S.
Randy, can I ask you a few questions about the Bear Lake project to the extent that you're able to answer?
Sure.
I mean, Mark was talking about variables associated with, you know, each site. And I mean, I think that's one of the things about this industry that's so challenging. I mean, each site is so different potentially. And so the ability to turn a profit, you know, is not a cookie cutter thing between sites to site. So I was wondering, I mean, you had on one of your slides about the presence of thorium that is easily stripped out with your process. I think it was in one pass, thorium and or cerium. I was wondering if about the sort of contribution of thorium disposal to the bottom line in terms of cost added in the production of product. So, you know, this is presumably a difference between production of rare earths in North America as compared to other parts of the world. So I don't know if you're able to comment on that specifically or with a percentage, but like how much more does it cost to produce a kilogram of purified neodymium praseodymium oxide because because Rare Element Resources has to pay for the disposal of the thorium?
Yeah, that's a really good question. I'm not sure I can answer it in detail, but what I can say is that as we've gone through the pilot plant testing, as we've gone through some of the design on the demonstration scale plant and everything, having to find a solution to thorium and thorium disposal adds significantly to the total cost of the project. Not necessarily capital cost, but on the operating cost side, that disposal cost is significant. And I wish there were an answer to what to do about that, but so far we haven't been able to find one.
Mm-hmm. And somewhat facetiously is a question about the europium content. What the heck are you guys going to do with all that europium that you produce now that the sort of applications for the element have changed? Are you going to stockpile it or something? Like, I mean, it seems like
no. One of the reasons I said we had a very high europium content.
Right.
But europium content generally throughout the rare earth resource space has not been very high.
Right.
but we had we had the most, if that's the highest content, but there still wasn't very much of it. So I'm confident that we'll be able to find some ability to market it in some fashion going forward, but we won't be producing all that much of it.